All right, determine the relation is a function. Number one. We have this graph. Is this relation a function? Yes. Why? Because it passes the vertical line test. Remember the vertical line test. So no matter where I draw a vertical line, that means that for this x value, there's only one what? Y value. For this x value, there's only one y value. So this is a function. Number two, you dealt with this relation. You had circles to deal with. So the circles you dealt with in that section 2.8 were those relations. I'm sorry, they were relations. And my question is, were those functions? No, because it fails the vertical line test, meaning that for this x value, there are how many y values? 2. So this is not a function. Three, remember that lines, are all lines functions? That's my question to you. Are all lines functions? No, very good. Which one? The vertical line. Very good. So a horizontal line is a function, right? And by the way, I just wonder if you remember this. What is the slope of a horizontal line? Do you remember? This is from a previous course. You probably forgot. 0. Very good. Slope of a horizontal line is 0. You're going to see that in section 2.3. If the slope is not 0, let's say it's 2/3, a positive number. If the slope is positive, what does the line do? Do you remember? It rises. If the slope is negative, do you remember what it does? It falls. But regardless, all of these are what? Functions. So all these are functions. You also talked about a line whose slope was undefined. That's a vertical line. So of all these lines I've drawn, a slope is positive, slope is negative, slope is 0, slope is undefined. Which one's not a function? First, second, third, or fourth? The fourth one. So all these are functions right here. This is not a function. And it kind of makes sense because when you look at the vertical line test for this x value, how many y values are there? An infinite number. There's an infinite number of them. All right, let's look at this one now. This finite set of ordered pairs, which we've done before, we've already done with this, is that a function? Now remember, some of you say no. Some of you like, I don't remember. Some of you said yes. Remember, the best thing to do is to draw that mapping. Remember that mapping? Okay, so you can draw a mapping. So you're going to have your x coordinates here, your domain, and this will be your range. Domain, range. There are a couple of examples where we use the words input and then what? Output. So you got to go back and look at your notes that dealt with this. And so when x is -3, what was my y value? 4. So far, when x is -3, how many y values do I have? 1. So far, it's a function. When x is -2, what's my y value? 8. Now remember, you only list it once, right? Okay, in fact, one of the worksheets you turned in previously, whenever you list a domain and range, you got to list the numbers just once. If it repeats, you only list it once. When x is 5, what is my y value? 8. I already have 8 listed, so just leave it alone. Go, just draw an arrow to it. What was the definition of function? For each x, there's got to be 1y. So when x is 5, do I get 1y value? Yes. What is it? When you say no, you better tell me another y value for 5. Right? When x is 2, what's my y value? So notice for each of those x values, there was only one what? So when we had the discussion a while back, it's okay for a y value to occur more than once for different x's. So this is a function. What you don't want to happen is this. So let's suppose I'm trying to find paper. Okay, let's suppose I had this one. 0, 2, 1, negative 3, 5, 1, 0, 8, negative 2, negative 7. Is that relation a function? Remember, relation set of ordered pairs. So everything I've done so far have been a set of ordered pairs. They've all been relations. Is that a function? No? Yes? No. Okay, I hear more no's this time than I heard previous problem. What part of this makes it not a function? When x is 0, I have two different y values. What are they? 2 and what? 8. Definition of function says that for each x coordinate, you better have just one y coordinate. So that's the one that makes this not a function. So this is not a function. Number 6. Y equals 3x minus 1. Is that a function? Now you have enough information for what we're about to do with these, with the few that we have left, to be able to, in your mind, remember what the graph looks like. What kind of relation is this? It's linear. So we said that all the linear relations were functions except which one? The one that gave you what kind of graph? Vertical. So if I were to draw this, if I were to graph this, do you remember what the graph is? To graph a line, how many points do you need? Just 2. So if x is 0, what's my y value? If x is 2, what's my y value? 5. And in fact, no matter what, if you think about it, no matter what I use for my x coordinate, how many y values would I end up having? Just 1. So if I look at the graph, here's 0, negative 1, here's 2, 5. You get this relation. Does it pass the vertical line test? Yes. What I'm saying, though, is that you didn't have to graph this. You just had to notice that this was a linear relation, and all linear relations are functions except which line? Vertical. And a vertical line, remember, looks like this. X equals 3. There's no y. X equals 3. Remember, this means, even if you look at it in terms of a t-table, look at this in terms of a t-table, this means that x always equals what? 3. Remember that? No matter what y is, I'm making some values up for y. But notice, you see right away it fails the definition of a function. Because if I look at this in terms of a mapping, there's only one value for x. What is it? 3. And how many values for y are there? An infinite number. 2, negative 3, 5, 0, and so on. So this is not a function. Okay. What about number 8? Y equal 2x squared minus 3. What kind of relation is this? It's quadratic. What does the graph of a quadratic relation look like? That parabola. So I don't know what this graph looks like, but it's a parabola, right? And you know that all the parabolas look like this. So in your mind, you know what it looks like. So does it pass the vertical line test? Yes. So many of these, when the equation is given, like number 6, like number 7, like number 8, you know what the graph looks like just in your mind. So you just think of that vertical line test. Even if you did not remember that this was a parabola, you could have done a t-table. Do a t-table. When x is 0, how many y values do I get? 0 squared is what? 0 times 2 is? 0 minus 3 is? So far I get 1 y value. When x is, let's say, 2, how many y values do you think you're going to get? Just 1. In your mind, you're figuring it out. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. Is that going to be the situation always? Yes. If I plug in 100 for x, 100 squared, whatever that is, times 2, whatever that is, minus 3, how many values do I get? 1. Hence, it passes the vertical line test. So that's a function. What about this one? Number 9. X squared plus y squared equal 25. Oh, please tell me you know what this is. It's a what? Very good. It's a circle. You have this in your test today. That's a circle. Because x is being what? Y is being what? In fact, well, right away you know it's a circle, right? And you know that all circles are not what? Functions, because it fails the vertical line test. But out of curiosity, what is the center? Because on a test you have to find the center of circles. Very good. Is the origin. Awesome. What is the radius? Yep. All right. So I think you're ready for 2.8. So this is a circle. So it fails the vertical line test, right? So that's not a function. All right. What about this one? Now, you may or may not remember something like this. It's okay if you did, but that's a square root function. If you don't remember what the graph looks like, do a t-table. Don't make it difficult for yourself. Do a t-table. If you don't remember what the graph looks like, do a t-table. So here's what I'm asking you to do. If x is 0, how many y values do I get? 1. Because look, what's 0 plus 3? And I get the square root of 3. Whatever the square root of 3 is, there's only 1 y value, right? If x is, let's say, 2, I get the square root of what? 5. 1 y value. If x is, let's say, 3, I get the square root of what? 6. 1 y value. Is that always going to be true? Yes. That's a function. The graph looks like this. So remember, when taking the square root, you can only take the square root of a positive number or 0. So I don't think we dealt with this yet in here. That's going to be in another chapter. But I'm trying to think if you did that last semester. I can't remember. But basically, the domain here is going to be from -3 to infinity. So you're going to start at -3. So it looks like this. That's what the graph looks like. So it looks like a sideways parabola. So that the square roots look like a sideways parabola without the other part. But it passes the vertical line test. So that's what the graph looks like. I don't think we've done anything like this. It's not on your test. I don't think we had it on a worksheet. But you didn't know what the graph looked like, right? So if you don't know what the graph looks like, then what's your next alternative to determine it's a function? What's your next alternative?
Oh,
T-table. T-table. All right, what about this one? Is that a function or not a function? You had something like this on a worksheet. It is a function because what does the graph look like? That V. That's the graph of a V. Where's the vertex? You remember how to find the vertex? What's the vertex of this thing? Remember, it's the inside. You got to think the opposite of what you would normally think. It's negative 4, 0. So here's the graph. That's that V. Even if you did not know that the graph was a V, what should you have done? T-table. So look at this in terms of an ordered pair. When x is 0, I get the absolute value of what number? 4, which is what? 4. When x is 2, I get the absolute value of 6, which is what? 6. When x is 8, I get the absolute value of 12, which is 12. When x is negative 4, I get the absolute value of what? 0, which is 0. So notice for each of those x values, I get how many y values? Just 1. Okay? All right, what about this one, number 12? What about if I had y equals x squared plus 6? Function, not a function. What kind of function? What kind of relation is this? It's quadratic. What's the graph? Parabola. So it passes the vertical line test, right? Remember, the graph here would look like this. So if you didn't know what the graph looked like, you do a t-table. In your mind, it makes sense because when x is 0, how many y values do you get? 1. 0 squared plus 6 is just 6. When x is 2, how many y values do you get? Just 1. 2 squared plus 6 is 10. When x is negative 2, how many y values do you get? 1. What's negative 2 squared? 4. 4 plus 6 is 10. All right, so that's a function. So there's a few more we need to look at before I give you that worksheet. But we'll go ahead and stop here with this.